Hello, this video is a part 1 of the series or section on direct, joint, and inverse variation. The first part we'll be doing math. We'll do some examples of all three of them, direct, joint, and inverse variations. And then in the second part we will be doing creating a Python program that will do that for us, that will solve any of these problems that we may come across. It'll solve for us. Okay, so let's get into it. Let's see what this direct, joint, or inverse variation is. This is from the book. It talks about direct, joint, and inverse. It gives us a graph here. It gives a quick description of what it is. The total high-tech spending in T, an average public college, can be found by using an equation T equals 203S, where S is the number of students. So that's like a direct relationship between T and S. Like if T is, if we're given S, then we can solve for T, and vice versa. They will change based on this constant 203 here. All right, so here they have a key concept for direct variation. It says y varies directly as x if there's some non-zero constant k such that y equals kx. K is called the constant of variation. So what direct is just a direct relationship between two things. Think of it like that. If one is increasing, the other one is also going to be increasing because our k will be constant, the other variable. And then we have we have a direct variation example here. They give an example. It says y varies directly as x, y is given as 12, x is -3, find y when x is 16. So they do the calculations and then they come up with an answer, y is -64. This isn't the approach we're going to use. So with that in mind, let's go ahead and jump into our OneNote. In OneNote, what I've done here is I borrowed the key concept from this section of the book on direct, inverse, joint, and then I've borrowed the self-checks on those, on each of those concepts. So there's an example, there's a self-check example on direct, there's one on joint, and one on inverse. So let me just show you what I mean. So if I go back to my book, it says there's a self-check here, check your progress. If R varies directly as S, blah, blah, blah. And if I come back here, I have changed it to X and Y here. But they're the same numbers, and it's the same equation and same setup that we're going to be doing. So with that said, let's go ahead and solve this problem. Let's go ahead and start solving. So I'm going to get one of these markers. All right. So the first problem, it says y, if x varies directly as y and x is -20 when y is 4, find x is when y is -6. First thing I'm going to do is solve for k. See, we're given here, let me highlight here, y equals kx. That's a really important information that we're going to use. So let's solve for k in the first set of chunk of numbers, because if we can label this, you can label this as, this is x2 here, this is y2, oops. This is y2, and then this is x1, and this is y1. So let's plug it. Let's do a plug and chug here. y1 equals kx1. So we have what? We have 4 equals k times -20. So k equals -20 over 4. This equals, oops, I did this wrong. This should be k equals 4 over -20 equals -1/5. The negative doesn't matter if it's numerator or denominator, and when we reduce 4 over 20, we get 1/5. So we solve for k, and now I'm going to plug this k into the second batch of numbers. So y2 now equals kx2. And y2 in this case, we said it's -6. -6 equals, we have k now, -1/5, and then we don't know what x is, right? That's what we're trying to solve for. So let's solve for x. I'm going to multiply both sides by 5, or -5 actually. -5 on both sides. This will get rid of our, both the negative symbol and the denominator. So what that does is we're going to cancel like this, and then the negative also goes away. So what that means is x equals -5 times -6 equals -30, or +30. X is +30. So that's our answer for the first one. All right, so the second concept we're going to look at is going to be the joint variation. The joint variation is very similar to the direct variation, except now we have introduced a new variable called z. Remember with direct variation, if I go back up, we had only x and y along with a constant k. But if I come down here, I have y varies jointly as x and z if there is some non-zero constant k such that y equals kxz. So with that new variable z, we use the same procedure as before, and we are going to solve for k. Based on the information that y equals kxz. So let's do that. Let's go ahead and solve for k here. Actually, before we do that, let's label our set of numbers so we don't get confused. Let's label these numbers first, and then we are going to solve the problem. So this is x1 here, this is y1, and this is z1, and then this is x2, y2, z2, right there, so we don't get confused. So let's solve for k in the first sub numbers. So we have y1 equals k x1 z1, and plugging and chugging, we get y1 is 10 equals k. We don't know what k is here. That's what we're trying to solve for. K times, we know x and z, of course, so x is 70 and z is 4. x1 and z1. All right, so that means what? So we have 10 equals 70 times 4 is 28 or 280. So I have 10 equals 280k. So that means k equals, we can just cancel one of the numbers like this. Just cancel, like cancel 0. Sorry, that's what I mean. If we cancel 1 0 out, and when we divide by 28 to isolate for k, isolate k by itself, divide by 28 on both sides, like this. If we can write an 8 somehow. So divide by 28, like so. So we are left with, the 28's cancel. 1 over 28 is k. K equals 1 over 28. All right, so let's plug this k into the second batch of numbers, the x2, y2, z2. So we have y2 equals k x2 z2. So we know k now, but we are solving for x2 here. So let's plug in numbers. So we have y2 is 2 equals, we said k is 1 over 28. x2 times, we know what z2 is. z2 is 8. Okay. All right, so let's do some cancellations before we divide by things and move numbers over to the other side. So 8 and 28 reduce to 2 and 7, like so. So let's do another step here. We are left with 2 equals 1 over 7 times x2 times 2. Okay, so let's come down. So I can now move the 2 over to the other side, divide by 2 on both sides. To isolate x, that's what we're trying to solve. So 2 divided by 2 is 1 equals 1 over 7x. So we can cross multiply or multiply both sides by 7. Multiply by 7 on both sides. So we get x equal 7. The 7's cancel. Notice the 7 cancels like that. And all we're left with is x is equal to 1 times 7, so x is 7. Okay, so let's do the last one here. We have a transitive, or not transitive, this is a, insert some space. Okay, that didn't work. Okay, let's see, we might have enough space here. We're asked, let's go over it, sorry, let's go over the concept. Y varies inversely as x if there's some non-zero constant k such that xy equals k, or y equals k over x. And x cannot be 0, and y can't be 0, because if they are, then we're divided by 0, basically. And we don't want that. So, the difference between this one and direct, this should say inverse. Let's go back to our drawing. This is inverse here. Inverse, okay? The difference here between this, we had y equals kx. Now we have xy equals k. So, but it is the same procedure. We're going to solve for k, and then we're going to plug k into the second batch that we need to solve for. So let's do that. Let's solve for k. We have r and s and t in here, though. Okay, or actually r and t only. Assume r is x and t is y. Okay, so k, we said xy is k. So xy, in this case, r is 18 and t is negative 3. So we have 18 times negative 3 equals k. K equals 18 times negative 3 is negative 50. 4. Okay. So now that we've solved for k, we're going to solve the second batch of numbers that were given. So we have r times t, in this case is negative 11, equals negative 54. So divided by negative 11 on both sides, negative 11, r equals 54 over 11. And let's see if we can get our calculator. So 54 over 11. We get 4.91. R is 4.91. And that's how we solve these problems with direct, inverse, and joint variations. All right, so this is the first part of the section on direct, joint, and inverse, and the second part will be the Python program that will solve it for us, that will create it, and without even doing any math. This was the strictly math part of the topic. Thanks for watching.